Welcome to this short video about the Zeebe Kubernetes operator. I'm working on this POC for. I've been working on this POC for the last month or so, and I wanted to show the progress on this front. So the idea here is that we are creating a component that will allow people to operate or manage Kubernetes Zeebe clusters inside Kubernetes, right? So the operator basically is encapsulating the logic on how to install new Zeebe, how to create new instances of Zeebe clusters with different configurations inside Kubernetes, and then how to monitor them to make sure that they're healthy, to make sure that all the components that are required for that cluster to work are there, and also to delete them, right? So if we want to clean things up, we should be able to do that easily. The way that operators works in Kubernetes is by monitoring and managing basically custom resource definitions. And in this case, for this operator, we created like a super simple custom resource definition for Kubernetes that is called Zeebe cluster. First of all, here in my terminal, I'm connected to a Kubernetes cluster in Google Cloud. So I'm connected to that one there, and I have nothing running there, right? So qctl get pods. I have no pods, and qctl get ns for namespaces. I have a pretty plain Kubernetes cluster there. I think that it has like 3 nodes or something, and super basic. So basically what I wanted to do now is something that if you are using Zeebe or if you're looking into Zeebe and Kubernetes, you might want to do in the future, right? So something that we have provided in the past is like Helm charts. So you can nowadays go to Zeebe helm.zeebe.io, and then you can just read this tutorial on getting started and just install the Zeebe cluster Helm chart, and then you will just have one Zeebe cluster up and running. That's fine. So if you want to have a single cluster, basically you just do that with Helm. The operator in this case, it's going to be in charge of looking after more than one cluster and understanding the state of it and providing tools for managing those clusters. So the operator itself, it's also a Helm chart that it's not listed in here just yet, but we will install it here and we will see how it works. So the first thing that we do is we add to our Helm repositories the Zeebe repository. Zeebe has been added. And then basically what we do is we fetch all the Helm charts that are available in that repository locally. So we have like a cache here of all these charts. The next thing is to install the Zeebe operator, and we do that by doing helm install Zeebe operator and then Zeebe operator, right? I'm just doing the plain default installation. And that's again using Helm in order to install this component inside the cluster. That was installed. Now I can do kubectl get pods, and I can see that I have some services running in here. So the Zeebe operator itself, it uses something that is called Tecton pipelines, which is basically an engine, a pipelining engine that allows us to run tasks inside Kubernetes, right? And in this case, we are just running pipelines in order to install Zeebe clusters or delete them, right? And then we have our Zeebe operator here that is in charge of monitoring Zeebe cluster resources. When I talk about Zeebe cluster resources, everything is up and running now. When I talk about Zeebe cluster resources, let's take a look at how that look like. And I have here one. It's a YAML file, of course, and it's kind Zeebe cluster, and it's part of the zeebe.io group, and it's version 1. And its name is my Zeebe cluster, right? So this is the example, the most simple example that we can create. If we create this resource inside Kubernetes, Kubernetes will not know what to do, but because we have our Zeebe operator, which is looking after these resources, that operator will pick it up and it will know what to do with it, right? This is the most basic Zeebe cluster that you can create. So basically with all the default options to be fully operational, right? So let's apply that file into the cluster. I'm doing that. So I'm creating the resource. The resource was created, and now the operator will look for that resource, and it will say something like, okay, there is a new resource being created called my Zeebe cluster. Is there a cluster already with that name? Zeebe cluster already with that name? There is no cluster with that name, so I will create one. And now what I'm able to do is I'm able to query using kubectl also like for these type of resources. So I can do kubectl get Zeebe, I should be able to see that there is a new my Zeebe cluster being managed already, and because it's been installed, it's pending, right? It's starting up, and whenever it's ready, when I have this status into ready, I will be able to connect my clients or my workers into that cluster by using that service name, which is under a new namespace. So if I do kubectl get ns, I can see that the new namespace was created and my Zeebe cluster will be installed in there. So I can do kubectl get pods my Zeebe cluster, and I can see that services are starting. At some point they will be ready. Now we are waiting on Elasticsearch, but regarding Zeebe, all of our services are ready and ready to accept connections, right? At some point when Elasticsearch is up and running, Elasticsearch will be able to start getting data from Zeebe, and that will automatically work. So I've created a cluster by just creating a resource now, right? But again, I've installed the operator in my Kubernetes cluster that is going to look after for these resources. Everything is running, so I have a cluster. Now creating a second cluster, it's pretty much the same thing, right? So I have another file which have another cluster with a different name, and I just wanted to demonstrate that the main idea of the operator is to handle multiple resources, multiple clusters. So -f. The trick here is that every cluster, every Zeebe cluster that we create, every resource, it's going to be handled in a separate namespace. That means that there will be full isolation and contention between resources between these different Zeebe clusters, right? So if each Zeebe cluster requires different, configurations for different SLAs, you can definitely make sure that Kubernetes will respect that. And the same with data isolation. Right now, as you saw before, as I showed you before, you saw that there is Elasticsearch being installed in each namespace. This is the default configuration. In the future, we are planning to provide you more options that you probably can add in these files here, down there in the specification, where we can say, well, I want this cluster not to use an Elasticsearch installation provided inside that namespace, but to use, a common one that is shared among different Zeebe clusters. The same will come for Operate to consume from different clusters or in each namespace. So I can do again kubectl get Zeebe, and now I can see that my other cluster is being created, and we should wait a little bit in order for that cluster to be ready. But just to finish this demonstration, one of the main things that you can do now, because we have the operator to take care of the installation process, we can definitely go and delete this resource. So if I do kubectl delete Zeebe cluster, the resource is deleted, and that basically means that our cluster is going to go away. So if we do kubectl get ns for the namespaces, we can see that my Zeebe cluster that was installed in that namespace is being terminated, and the namespace itself is being cleaned up, right? In the future, and when we create an operator, the main objective is to make sure that we provide all the tools and all the hooks to deal with these scenarios, with the life cycles of each of these clusters, right? What happens with the data? In that case, we are just cleaning up everything. But if you're interested in keeping the data of all the processes and all the workflows that you were running inside that cluster, when we delete the resource, we should make sure that we trigger the backup and we move that data somewhere else. So if you're interested in those running instances, you can take them somewhere in a different cluster or something like that. So all importing data and exporting data, doing backups, making sure that we clean up resources, and if we have a cluster that it's not needed anymore, we can just take it out quite simply by using the operator. If we are building UIs for doing management on Zeebe clusters, the UI should interact with these, with these mechanisms, and in this case, the operator using these custom resource definitions. So I will appreciate feedback about what you saw here, and questions are always welcome. And again, this was just like an intro video of how the operator is working. If you have more in-detail questions of how this works, please take a look at my blog post about this topic, where this video will be included. Thank you.